good? All right, cool. So, my name is Pinky. I'm going to be doing a presentation on PCB art. So first of all, what exactly is PCB art? Well, first of all, it's what's around most of your necks, assuming you have a digital badge. It's doing essentially PCBs in more of an artistic way, just not instead of the standard, green rectangle sort of thing. PCBs are composed of 4 different layers. For a two-sided PCB, it's composed of 2 sets of 4 layers. For the bottom layer is the substrate, which is usually a fiberglass. That's where FR4 comes from. It's fire-resistant, essentially fourth version. You can actually see that on this badge with that tan portions. That's exposed fiberglass, which is semi-translucent. The next layer on top of that is a copper layer. That is the traces, which are like the wires that hook up all the chips. That's how you make all your connections. On top of that layer is what's called the solder mask. Solder mask is essentially the insulating layer for the PCB, insulating traces and stuff like that. That is, actually you can't see the picture there. It's kind of someone on a Hackaday did a palette example for a bunch of colors of PCBs. This one, the tan layer they're showing, that's the fiberglass. The silver layer is the copper layer. It usually comes with a layer of solder. So that's why it's silver. The layer next to that, that's yellow semi-translucent. That is just solder mask. And then the layer after that, on the top, that bright yellow, that is copper with solder mask on top. It changes the colors. And on the bottom, you can see that white text is called the silk screen. That is how the manufacturer labels different parts, test points, stuff like that. They can be, and you can see the color kind of changes a little bit when you go copper underneath versus not. So that's kind of those 4 layers are your palette. And for a PCB, they can be multiple, essentially copper layers. Though for PCB art, the more artistic side, you're really only going to deal with 1 set because more layers are underneath. They're visible, but they're not visible. They're mostly used to connect stuff up if you have like parts with a bunch of connections on the bottom and you have a small board, you've got to route all those. So you need to have extra layers so you can actually route them properly. So for the kind of method I found that works for doing PCB art is I go design my thing in Inkscape, then I'll put that in KiCad, which is an open source PCB design software. Inkscape is as well. They're both open source programs. And then, make my image in Inkscape, design it, import into KiCad, and then turn that into the layers that make up the PCB. So the process for doing the Inkscape side is I will import an image. It could be anything from a JPEG, PNG, stuff like that. Import it into Inkscape, and then after I import it, there's a trace bitmap function in Inkscape. And what that does is it converts it into a kind of editable image, a kind of black and white image. So then you can use Inkscape's vector art feature because Inkscape is a vector art program and edit your image from there, delete sections, add sections. You can even make stuff in Inkscape and export it. But after you make, import, design, both, whatever in Inkscape, you will export it out of Inkscape, or at least what I do, into an SVG. SVGs are what called scalable vector graphics. It's a image format that is essentially designed that you can scale it as big or as small as you want without a pixelation on the edges. That's the SVG is kind of one of the main image formats that KiCad takes. So give you an idea of what it looks like. So on the left side, we have the trace bitmap with kind of a preview image on the bottom. The functions on top just let you change how it views the image, like what its threshold is for black versus white. Because if you put in like a gradient image, it will get confused because it's trying to turn everything into 1 or 0, black or white. So it's usually better to pull in images that are already close to that. So there's less cleanup that you have to do. Then the export function, which you can see on the right, kind of basic export image type things. You can change the size, location, et cetera, et cetera. So I've got it. Like any good cooking show, I've previously prepared an example. So we will import, I'm going to import that image. Go under Spirit Blossom. So there, this is now, I forgot to grab my mouse. So this is now an editable, or it has been pulled in. This is just an image, hasn't been traced over yet. So what you do is, you go under your pull up trace bitmap, you can edit, the different cutoffs and things like that for the trace. Hit apply, and now, this was the original image, you can delete that, and now this guy is a editable image. So I can grab any of these points, change angles, change lines. Excuse me. Oh, right. Change lines, stuff like that. And once I get my image to a point that I'm satisfied with it, I'll go under export, like we showed. Export selected is useful if you have multiple images. When I do build stuff in Inkscape, a lot of times I just pull up a new document and just throw a bunch of images on and export them as needed, kind of like a scratch pad. But you can also obviously save these as SVG in Inkscape as well for future reference. But I will let's make sure to send this to the desktop. Save. Double confirm. Yep. So that's now on the desktop as an SVG. Close this. And we can keep going. All right. So once you have all your SVGs created, you can pull them into KiCad and start setting the different layers, board layers in KiCad for doing different, for the copper layer, the solder mask, the edge, what's called the edge cuts. Edge cuts is kind of, the name implies, is what the outline is going to be of the PCB. Kind of nice thing with KiCad is it really doesn't care what type of image or what type of border you put in. It just has to be a complete, a solid shape. So it can't be any holes in it, because it's trading like, okay, this outline where it's a star, circle, whatever, is going to be the edge of where the PCB gets cut out. So you import your SVG into KiCad, and I'll demonstrate this in a second. You import them, when you import the image, you set which layer of the image you're doing. Like, it's the copper layer, it's the solder mask layer, it's the edge cuts, et cetera, et cetera. And then you can move all those images around. And once you have all of your edge cuts, your copper layer, your solder mask all finished, you could export that out of KiCad, and then that's the files you send to the PCB manufacturer. It's called plot. You call plot because the original PCB manufacturers were on a giant table. They would cut everything out by hand, and then they would send it to a plotter, which is kind of like a printer, to make the actual design. So that's where the name comes from. So get more examples. On the left, under the PCB editor, that is what each of the layers is going to look like, at least in the latest version of KiCad. The yellow circle around the outside is the edge cuts. Or edge cut. So that defines that, okay, it's going to be this shape. The red section in the center is a front copper layer. Is the front copper layer. KiCad uses different colors for the front and back, so you can distinguish, and you've got a couple things stacked up. Excuse me. And on the other side, KiCad has a 3D viewer where it'll take your design and kind of make it into an actual 3D viewable PCB. So you can kind of make sure that everything's together, everything looks right, is set correctly, stuff like that. It'll give you errors like, if your edge is incomplete, it'll throw errors, things like that. So now we'll pull up KiCad. And we will just give you an overview of KiCad. So the way it works, if you're designing it like an actual functional PCB, which can be PCB art can be still functional PCB, you first will make it what's called a schematic, which is laying out like, okay, batteries here, LEDs here, this here, and you link it up, kind of the classic like mechanical drawing schematic. You then set all of the parts you made in your schematic, you set the footprint for them. Footprints in KiCad is kind of like this image right here. Footprints define on the actual physical PCB what the exposed copper areas for that part are going to be. So if it's a through hole part, which means it goes right all the way through the hole through the board, it'll be where all the holes are for like putting components in. If it's a surface mount, which means the part sits on top of the board, footprint defines the spacing of all the pads. So if it's a 6-pin IC, kind of like the little picture, it'll look like that. It can define spacing, things like that. So I'm going to open the PCB editor. There we go. Now I'm going to do, so import graphics. And so this is kind of the import window, like I was talking about for the import window for pulling images in. So this outer ring, I try to label when I'm doing stuff in Inkscape, because Inkscape you can set scale things to an actual like inch size. I try to label those so I know, okay, this circle is a 3-inch circle, or this square is this big, for reference when you're pulling it in here. So this circle I'm going to set as the edge cuts, like I talked about. So this is layers. This, I'll actually show that in a sec. You can also scale. So like if maybe you made something that was slightly too big for the PCB, you can set the scale to like 0.8, so it shrinks it down. So you don't have to keep going back and forth. So open. So there is the. There you go. Nice using a trackpad. So there's the outside of the PCB. Actually, I'm going to pull. So as I said, edge cuts can be kind of anything you want for size-wise. You're not restricted with PCB art to the normal. Hey, there we go. To the normal default. So I've got that. And if I pulled up the 3D viewer for here, now I have, might be kind of hard to see, this is the PCB. So after I've got that open, I can pull in using the same process, pulling that image I made earlier. And important thing when you're doing images like the one I did in Inkscape where they have multiple pieces, it's useful to have the group imported items, because that makes sure, actually, oops, that's an edge cut. That makes sure that all the different pieces, you can select them all as one, because otherwise, if you're trying to arrange things or do other things, like each of these parts will be treated individually, which you can still edit individually. But it's nice if you're like trying to like align this with the inside of this. If these are all individual, squish them all together because it's treating it individually. That is actually an option you can do here if you want to align objects together. What you do, align distributes. You can actually align horizontal and center things, which is kind of handy. So I've set this as the copper layer, so it'll look like the picture I just showed you. And the thing is, so this is a copper layer underneath the solder mask, and you can kind of see, as I said, solder mask is semi-translucent, so you'll see the copper, and this will be a raised area. But for this, if you want it to actually be exposed, the actual copper layer to be exposed, you have to add, there is a layer here called the mask. And essentially what mask is mask defines what parts of the PCB will have, what parts of the PCB will not have solder mask on them. So you can, if you want expose copper, you could even use it to expose, like these badges, expose the actual fiberglass layer, which is that tan layer. So the fiberglass layer is semi-transparent, and actually, as you can see on here, it shines, with LEDs inside, it actually shines through. So, little extra visual flair. So, got that. So after you get your PCB all finished, you got the board the way you want it. Actually, I'll show you. So this, now you can see it's actually an exposed. This is a type of edge surface finish for the copper called ENIG. It's like gold plating, essentially. I'll talk about that in a sec. It's an option you can get with some of the PCB manufacturers. So what you do once you have it all done, you'll go plot, and this is just setting all the parameters for the files that will be sent to the board house. And then changes. Keep going. All right, so board creation. So once you have the files actually finished, you'll be sending them off to a board house. The board houses, the two I've dealt with for doing my PCB art is Oshpark and JLC PCB. Oshpark is a US-based company. They mainly do their colors are a bit more restricted and they're a bit more expensive. And they do take a little longer, but they are based in the US. So there is if you're required to for whatever reason, or you just want to support US companies, that is an option. Their like main two color schemes is this upper one. This is a modification of the Throwing Star Land Tap by Great Scott Gadgets. I did, the files are open source, so there is a KiCad file for this project file. So what I did is imported it. I changed the edge cuts to this pixelated style. I actually made it in a pixel art software, converted it to an image, put it in Inkscape, and then did the creation process like we just talked about. So, but their main thing is purple solder mask with the gold finish. That's kind of their specialty. And they also do what's called an After Dark. And After Dark is a clear solder mask with a black substrate and gold finish. It's useful for debugging because you can see traces, stuff like that. And it looks pretty cool. The orange down here, the 4-in-4 ever, is actually a gold finish with the clear solder mask on top. So the solder mask will change the color, so you can use that as an option. And also the one I've used a bunch more is JLC PCB, Chinese-based board manufacturer. Their stuff, they have a lot more options and they're pretty cheap and they have pretty good shipping. So they were the ones I got, these two kind of poker chips in the corners and this orange one, which is a flex PCB. A flex PCB is essentially that the fiberglass, instead of fiberglass as the substrate, it's a polyamide, it's a plastic. It's kind of like Kapton tape without the sticky part. So it's flexible. Used a lot in the production world for hooking up things or making custom wiring harnesses, because you can design it flat and it folds up. These are flexible flex PCBs. I believe Oshpark offers that as well. I've just not used them. So different places have different capabilities and colors and such. Other nice thing, talk about capabilities. All these places offer anything from like a 1-layer board up to like a 20-layer board. Obviously, as I said, a 2-layer board is kind of the max you get for PC if you're doing purely decorative PCB art, because anything else isn't going to show up. So it's just going to be more expense for not much more. And some places like JLC PCB actually offer machining and 3D printing services as well. Same sort of process. You make a 3D file in like Blender and upload it to them, and they'll make it for you. Actually, pretty cheap. So it's kind of an all-in-one stop if you want to maybe you want to make a board and make an enclosure. Kind of nice to have both. There are different colors and finishes or materials, for lack of a better word, that they offer at the board houses. Like I said, there's regular and then there's like flex PCBs. And color wise, the main solder mask colors that are offered, kind of primary colors, so red and primary and secondary, so red, green, blue, yellow, black, whites, and something like that. So there's different color options that affects your palette of what you're doing for your art. And there's the finishes covers, like I was talking about before, the ENIG, electroplated nickel immersion gold. It's a nice shiny gold finish. It's a little more expensive, but it is much more robust. It's more corrosion resistant. It's a bit easier to solder to, because the normal finishes for these, if you're not getting the ENIG, is they'll just do a solder layer over any exposed copper, lead or lead free, depending on what you select, which works for functional boards, but for more decorative stuff, I found it wears off a lot more easily. So, but the option is there if you want to use that. So yeah, so that's kind of at least my experience with PCB art. A lot of this has just been me playing around with it, because Inkscape and KiCad, as I said, are open source. So it's easy if like I ran into an issue or something bugged out in a weird way, I could go Google it and there's 4 other people who've had the same issue. So I can go find, oh yeah, maybe I tweak this here or tweak that there. So if you're wanting to do PCB art, a lot of it is just like setting down your computer, like, oh, that's like, you find a cool image, like, oh, that would be kind of neat to do on a PCB. And you play with it, iterate through it, like until you can find something that you like. That's actually where I got with the 2 poker chips. Those exposed fiberglass sections were actually supposed to be exposed copper, like the exposed gold finish. I was just doing a full copper fill for it and forgot to add it back in before I sent the files out. But it turns out it looks pretty nice because the design is on the same on both sides. So you actually get a nice shine through effect with those. So you get happy accidents like that. And lastly, I want to thank the Little Bit Space was the guy who did the ASCII SIG I have on here and on the website. He does really good ASCII art. Recommend checking him out. And the fonts, credits for the font, the pixel art font that I use for this. So that's all I got. So any questions? Well, whatever. Go ahead. Or. Mhm. So the question was like for the exposed fiberglass layers, does it still feel like fiberglass? It doesn't because it's if I remember correctly, it's like fiberglass but not. So it's not like. Sorry. You good? Okay. Yeah. So it's essentially just it's if I remember correctly, it's like fiberglass but not. So that's yeah. I mean, you can rub your hand across this. You're not going to feel any exposed. So it's a composite of some degree. So you're welcome. Yes.
When you have to do drilling,
Mm-hmm.
is that similar to doing the masks, specifying the masks, or is there a different process for specifying the drill?
The drill. Oh, so the question was about doing the drill kind of functions for like if you're doing through hole, which will has stuff drilled through the board. Assuming I'm answering your question properly. Oh yeah. For the I see what you're saying. So when you do, so this is the output. It's the Gerber output. The Gerber is kind of the standard PCB house file. There is so this is the standard just for doing all this like traces and stuff. There is a generate drill file that will do that. So it'll do it as part. If you have parts, excuse me, it will do that as part of kind of the generating the files. If you have through hole sections, or you choose to define holes like for like screws or whatever, because you can put I can have an edge cut outer layer. I can put an edge cut like a little mini edge cut circle, and it'll still actually I can probably show that. It'll still show that. It's just a matter you have to make sure you generate the drill file. So that's kind of for doing drills. It's kind of just I know there's sometimes when I've done when I've sent them off to like JLC where it will actually want me to provide a drill file even though I'm not doing any drilled holes because it's just you send for JLC at least you send them a zipped folder of all the Gerber files and then they take that. So let's see. So say I set this to 0.5. Find that. So I have two edge cuts. So there you go. They find it's a lot of these, and that's kind of the cool part I found out with doing the Inkscape to KiCad is essentially it'll take all sorts of random shapes and images and such, as long as it's like I said, as long as it fits the requirements, like with the edge cuts where it's saying, hey, this has to be a complete image or a complete shape. So if there was like if it wasn't complete circle, it would bug out because it's like, hey, I'm trying to define a closed area and it's not a closed area. So it's just kind of a lot of there's a lot of things you can do with this. Just kind of that's why I figured out playing around with like, oh, cool, this is a cool image. I wonder if I can make it work, and I did. And sometimes you can, sometimes you can't. Is what it is. It's kind of part of the process. Hopefully that all answered your question. Yes.
I have a third question, so I understand the company back too. It's more about KiCad, I guess. I'm looking to make a decorative circuit board design, but I don't need an actual board. I'm just looking to make a design. One, is it good for making a layout like that instead of me photoshopping traces that I would be estimating? If it fills in things for chips I'm not actually going to put into something. And then two, is there can it export to either what is it, paths or even just an image file to use for what I'm using it for?
Are you talking about KiCad or Inkscape?
For KiCad,
For
Inkscape is just
Yeah, Inkscape is an open source vector drawing program, which is lines essentially.
So basically, would you be able to put it back to a vector file?
I'm
Or my utilization of making a 3D printed, completely decorative one, or
maybe
like I said, even image to use that with too. I
I'm
guess it's just a generic question, I guess, about ICAD.
no that's fair. I mean, I'm looking right now. There is an export option for SVG, so I'm not gonna say yes, it'll definitely work, but it's as I said, it's kind of I find the fun of like, screw it, let's see what happens.
And then so and also if I did put quote unquote chips in there, does it automatically generate traces based on
What it
input, or
what
you
it
have to like draw them out yourself between connections
what
or whatever it might be?
Oh yeah, yeah. So the way KiCad works, so I make my schematic, I define all the footprints. What it does when I go into this PCB editor section is it lays out, kind of like squishes all the arranges all the parts, all the footprints, and then you have to kind of you move them where you want, and you have to draw the traces because that's how you define. Okay, I need to go around this. Somewhat, they're
It's not hand drawn, I guess.
not quite. Yeah, it can. There are auto routers for these sort of programs. They're not recommended to be used a bunch because they're not particularly good. But there are some. There's a guy who does an add-on for KiCad where you can actually make the traces curved, or he calls it melting the traces because it makes the sharp edges to like the classic 80s PCB design where it was literally drawn by hand. So there are, that's you essentially all your footprints, connect them all up, and there is I think it's under.
As long as the Goetzman is all, like I said, looking for something that would look like a PCB without me hand connecting them in a, like I said, Photoshop or Vector.
I mean, yeah, you'll still have to hand connect them in KiCad, but the nice thing with if you're using a schematic and you define the footprints and everything, it will actually keep track of what's connected. And it's called the design rules checker. It's common for like PCB stuff. You can run that, and if like something's not connected, it'll tell you like, hey, you forgot to connect pin 2 of this to this. It's kind of a nice if you're doing a huge PCB and you can't keep track of. No, I've considered doing something like making just like decorative traces, because you can this thing does have an option in KiCad just to draw lines, so you could you get the idea. So you can draw your own traces. So that is an option. That's actually something I've considered before. So cool. Any other questions? Cool. All that good?